All right, in this problem, we are looking for the Ka of an acid given a pH value. These are very similar to the kinds of questions we saw back in the equilibrium module before we even started talking about acids and bases. We've just introduced some new vocabulary here. I have an acid, a weak acid. I know it's weak because there's a Ka value involved. So I know what the equilibrium reaction it is that it's talking about. For a weak acid, this is the generic equilibrium reaction that I can write, and I should write. There's going to be an ice table, and I'm going to calculate the Ka for this reaction, which will be the concentration of H plus times A minus all over the concentration of HA, where those concentrations are at equilibrium. I need this row in my ice table to be able to calculate that Ka. Well, I know the molarity of the acid solution. That is the initial concentration of the acid. They're written in scientific notation. This is the way that our eLearn program works. It looks a little weird. 8.61 times 10 to the minus 2, which, if you want to go ahead and take it out of scientific notation, it's 0.0861. So you can do that. That is my initial concentration of my solution. Now this pH value, the pH of 2.4 times 10 to the 0, that means my pH is 2.4. That's going to be related to the hydrogen ion concentration at equilibrium. That's where I'm going to get that equilibrium amount of hydrogen ion. How do I know that? Because in our previous module, where we started learning about acids and bases, we had an equation which relates pH to the hydrogen ion concentration, and that is the hydrogen ion concentration at equilibrium. So from that pH value, I know my hydrogen ion concentration at equilibrium. There are several different ways that I can write this. I'm going to write this as the H plus is equal to 10 to the H plus concentration is equal to 10 raised to the negative 2.4. It's the inverse log of the negative pH. Again, there's different ways I can represent that algebraically, meaning the same thing. So there is my equilibrium concentration of that H plus, and I'm just going to write it as that right now. I could actually plug that in my calculator, get an answer for it, but I would want to make sure that I wasn't rounding in the middle. I would want to keep extra significant figures. I'm going to 2 sig figs in my final answer. I probably would want to keep 3 or even 4 significant figures in that answer. All right, so here is the beginnings of my ice table. Since this 0.0861 was the initial molarity of the HA, as we did back in our original equilibrium module, the initial amounts of the products are 0. If I know the equilibrium amount of the H plus, that means the change was plus 10 to the negative 2.4, which means the change in my A minus concentration was 10 to the negative 2.4, which means the change in my HA concentration was minus, I can't talk and write, 10 to the minus 2.4. So now I can finish filling out my ice table. Now I'm going to just write this in terms of these and then plug it one time in my calculator. Again, you could go ahead and calculate some values in the middle. You just would need to make sure that you're not rounding in the middle, that you're keeping extra significant figures. But now I'm ready to calculate my Ka. Remember, this is my equation for the Ka. So in the numerator, I have 10 to the minus 2.4, and that value is squared. It's the concentration of H plus times the concentration of A minus, all divided by the concentration of HA, which is 0.80861 minus 10 to the negative 2.4. You do have to be a little careful plugging it into your calculator if you're waiting until now. Again, if you're not waiting till now, if you're plugging in values in the middle, you want to just be sure you're keeping extra significant figures. I don't like doing that just because I don't like re-punching in everything. So I'm going to punch this in my calculator. You should be punching it in your calculator as well to make sure that you get the same thing that I do. So here we go. I'm punching it in. This is one of those calculations where it's so easy to go wrong. So you might want to make sure, I can't talk in right. You might want to plug it in a couple of times until you get really comfortable with your calculator. So that's the numerical answer that I get for the value of Ka. You want to report it to two significant figures. All right. And so you'll do that in scientific notation. So you will be typing in 1.9, and then it's got the times 10 and then the little box for the power, and you'll raise it to the -4.